Good morning from NASA's Jet Propulsion Laboratory in Pasadena, California. It's hard to believe it's been less than 36 hours since NASA's Mars Curiosity rover landed on the red planet. Already it's wowing us with its images and data that's being beamed back to Earth, and we're going to hear more about what's coming down already and what's coming up in the weeks and days ahead from our panelists. Let's go ahead and introduce today's speaker. We're going to hear first from Michael Watkins. He's the Mars Science Laboratory Mission Manager at the Jet Propulsion Laboratory. Ken Edgett is the MAHLI Principal Investigator with Mail-in Space Science Systems in San Diego. And Sarah Milkovich is the High-Rise Investigation Scientist, also from here at JPL. We're going to start this morning with Mike Watkins.
Okay, good morning. Curiosity had another busy day yesterday, and she's asleep right now, getting ready for tomorrow. But as usual, at the end of the rover day, we get a call through the orbiters with the status for what happened with that day's activities. And Curiosity is still healthy, still what we call surface nominal mode, and still in great shape. Now, yesterday's activity started off with the high-gain antenna deploy, and I think I talked about that yesterday. So on this rover model, this is the high-gain antenna right here. So we want to get this antenna, this small antenna deployed, and that allows us to talk with a little bit higher bandwidth to Curiosity, and allows her to talk to us directly via the big antennas at the Deep Space Network. We've always been talking to her through the orbiters, since EDL night. Now, the first thing that it has to do is deploy and go through a range of motion, and that was successfully done. The mechanism, the antenna mechanism, is in fine shape, but it was not quite pointed accurately enough at the Earth for us to get the telecom signal that we wanted. Now, we've looked at that pointing. That's a parameter that we can set. There's a little bias in the pointing, and the telecom folks and the antenna mechanism folks have taken a look at that and have a correction for that bias, and we're going to send that up with our next command load and establish direct-to-Earth communications via this antenna on tomorrow. Okay, the next thing that happened yesterday was the initiation of some science observations. We turned on the RAD instrument, and in fact, the PI of RAD, Don Hassler, is right here in the audience, and acquired several hours of excellent RAD data that the team is now taking a close look at. We also did the first sensor diagnostics, sensor calibrations for the RIMS instrument, and we acquired a few minutes of RIMS data, and that worked successfully. We then tested the MAHLI focus mechanism and acquired our first MAHLI image on the surface, and Ken Edgett will talk about that just shortly here. We also took what are called dark images from our navigation cameras and the Mastcam. So the remote sensing mast, which is this mast, is folded down like this, and the cameras are facing down, and allows us to take an image with no light in it to see if there's any bright pixels in there that we need to subtract away to get the best possible quality images later when we are deployed. And those executed successfully as well. We then wanted to turn RIMS on and acquire some additional RIMS data, and that test did not work correctly. The RIMS instrument has a lot of parameters that control the frequency of its observations, and I think they're taking a close look at whether those parameters were set the way they want to. So the RIMS team is taking a look at that right now. But the sensor diagnostic that occurred earlier in the day was successful. So we think this is just a function of how their observation table parameters are set up. Okay, now the plan for tomorrow is mentioned is to establish direct-to-Earth communications by slightly changing the pointing of the high-gain antenna, and we're also going to deploy this remote sensing mast. And actually, we have a video of how that should look when we did it in assembly and test before launch. So if we could see that video. Okay, so here it is. So that is a remote sensing mast. It's quite a huge thing, compared to previous missions. What you see on the top there is you see a big white box, and that's actually part of the ChemCam instrument, right? That will eventually fire a laser at rocks and allow us to remotely determine composition. It contains both a camera and a laser. And then below that is our primary imaging systems. So you see 4 little silver cylinders there. Those are redundant navigation cameras. And then in between those, you see kind of a square and a round camera, and those are the Malin Space Science Systems Mastcam cameras. So those are the highest quality color imagers that we have. So of course we want to get them up on top of the mast and get them up high. This mast, you could not look this in the eye unless you were probably an NBA player. And so we want to get these up high and take a good look at the horizon and start taking our stereo photographs and our color photographs. So this is one of the key activities for tomorrow is to deploy. We received enough telemetry today to say that that mechanism is go for deploy, and so we see no reason that that's not going to function successfully tomorrow. We're then going to take it to look back at our own deck and take a navigation camera parameter. Actually be a 360, but we'll kind of start at the deck and look around, and then we'll also take an image from the Mastcam of the calibration target, the Mastcam calibration target. So I think that's everything for tomorrow, and I mentioned we took the first Molly image yesterday. So Ken Edgett.
And you might not be able to look the mast cameras and nav cameras and ChemCam in the eye, but the Molly can, because the Molly is on the end of a 2-meter-long robotic arm, and we can position Molly anywhere that arm can go. We can go straight up, we can go all the way down to the ground, we can get within an inch of a rock or an inch of soil and take a close-up image that's about twice the resolution of the MI, the microscopic imager on Spirit and Opportunity. Right now, the arm, I guess I should just show there's an animation. Right now, the arm is stowed and the turret is stowed, and when that's happening, the Molly is just pointed off sort of the left front shoulder of the rover, and that just happens to be right now pointed directly north from where we've landed. So you see in the animation the field of view of the Molly there. It's about 38 degrees in a diagonal sense. There's the Molly. And there's the image we got, which we put out overnight, and we'll talk a little bit more about that in a minute or so. The Molly is a focusable color camera. This is the first color image of the landscape where we've landed. And like I said, we'll talk about it some more in a second. I waited a long time for this to come back. This was basically a focus test. The focus mechanism itself has not moved since July of last year when we were down in Florida. And we've gone through all those environments of launch, cruise, EDL, and the temperature cycles. And does the focus still focus? And it does. Now, we also have a dust cover because most of the time we don't want dust on the lens. We don't want dust on the lens at all, but most of the time we'll just keep it closed. For this first image, we said, let's keep it closed. We can focus whether the cover is open or closed. So we thought we'd better keep it closed because we don't know the state of, how dusty the Molly is after landing. And let's look at the next. There's a picture of, this is the hazard camera, the front hazard cameras that you've seen this before. The one on the, I guess it's my left. I don't know if it's your right. But there's one that's really dusty, right? That was before the hazard camera's dust covers popped off. And then the other image is not so dusty. That's after the dust cover was removed. On the Hazcams, those are off and they stay off. On Molly, the cover will open and close when we want to use the Molly with the cover open. So let's go to the next image, and again, this is the image that Molly took, and you can see that the cover has dust on it, and so the scene is kind of murky. It's actually somewhat pathological because we're facing north, and the sun, it's still winter there, and so the sun is kind of high and sort of northwest of here, and at this time of day, and so you're just kind of getting some of that scattering off the front of the lens. So it makes it look even more murky than it actually is. It's not a dust storm, and it's a clear day on Mars, and the lens is just a little dusty. One of my co-investigators said, looks like the dust cover did what it's supposed to do. And I was like, yes, it did. But the other point is the camera did what it's supposed to do. It found focus. When you look at this, the image online, you will see that you can see rocks in the foreground. And you'll also notice it's kind of blocky. That's the compression. because of the fuzziness on that, of the dust, it sort of over compresses it, right? If it was clean, you wouldn't see that. So it works, it's awesome. Can't wait to open it and see what else we can see.
Yeah, we should have called this the dust cover test.
The dust cover test. Well, it's a focus mechanism test. We'll test the dust cover later on after we're certain that we can open it. So first we'll take a look at it with the navigation cameras on the mast and stuff. I guess there's one more picture. This was sort of gives you a sense of what the image looks like in context. This is digital terrain derived from topography, from images from a lot of orbiters, from Mars Express and Mars Reconnaissance Orbiter, all put together, and then we placed the MAHLI image in there to give you a sense of what it looks like. And then we made that MAHLI image a little bit transparent so you could actually see the stuff behind it, but it all lines up real nice. So, and I think I covered all my points. On to you, Sarah.
Okay. Well, so yesterday I was here to show you a fabulous image that HiRISE took of Curiosity coming in through the atmosphere. And today I'm here with another fabulous image of Curiosity on the surface. So this was a special sequence we did. Normally, MRO only it rolls within 30 degrees either direction as it's traveling across the Martian surface. For this, we had to roll about 41 degrees in order to get this image. So it's not as good quality as images that we are going to get later, but we wanted to get an image of the surface as soon as possible after landing. So if we could go to the first animation. So we're zooming into the landing site here. And the image you're going to see, it's actually, the view is as if it's tilted 45 degrees. So there's the full HiRISE image. Because the roll of 41 degrees, we're now seeing part of the planetary curvature, so that the image is a little skewed. And this is what we're calling it's like a crime scene photo here. So this is about 39 centimeters per pixel, and at this location, the MRO orbit is about 300 kilometers above the surface. And we can see just all of the components of the whole EDL system. So if we could keep going. So we're zooming in. Here is Curiosity. That sort of spot at the center there is Curiosity. And the dark streaks on either side, that's where the bright dust has been removed or disturbed as in the course of landing. And one thing that's really great about this, we predicted the position. By looking at these dust streaks, we can figure out what orientation we think MSL or Curiosity is. And if you keep going, on the animation, we can see we have knowledge from, we don't have it on this one. Okay. Well, we have knowledge from MSL itself, and it matches up just perfectly. So it's a really nice feeling when you have, you're getting the same information from orbit as you're getting from the ground, and that really makes you feel very good. This is the parachute and the back shell, and you can see as you look closely at this, you can see some of the features on the parachute that you were able to see in the EDL image. The nice the bands. All of these images, again, because of this this angle that we took this image at, it's looking through a longer column of atmosphere. So there's a lot more dust that we have to look through in order to see these, and also from looking at the dust covers on the various cameras on Curiosity, we know that a lot of dust was kicked up over the course of these events. So hopefully in our future images, we'll be able to get even better, more detail in these. So if you go to the next one, and again, the dark areas here are where the bright dust has been removed. So I think next is going to the heat shield. And so you can see the heat shield and, again, disturbance around the heat shield. And if you could keep going. And finally, the sky crane. So this pattern is consistent with an oblique impact. So coming in as your the dark areas is sort of downrange of the impact. This is what we see if we had meteorite impacts forming craters on the surface of planetary bodies, and this is the same sort of pattern that you get. And if you could keep going. And we don't know, we're still looking at all the details of what's going on. This image was taken at about 10:30 last night Pacific time, and then it takes several hours to get it down and to the high-rise team and processed. So we're still looking at the details here. I have some distances for you here. The distance between the Curiosity rover and the heat shield is about 1,200 meters. The distance from the rover to the backshell parachute area is about 615 meters, and then to the sky crane is 650 meters. So just to try and give you a sense of perspective here. So we are next taking an image 5 days from now is the next time that we're able to take an image of this area. And this one we are going to be able to target with the updated coordinates for where we know we actually landed. This image was taken with, we were targeting the very center of the landing ellipse. So this is with where we thought we'd get to, from before we got there, basically. So we're hoping that in the next few weeks we'll be able to get a couple more images of this area. We're going to try for some color in this area as well. So that should be very exciting. So stay tuned for that. Thanks.
All right, thank you, Sarah. Thank you to all our panelists. And again, as I stated at the beginning, it's amazing. It's just been 36 hours, and already what we have seen and more, and the best yet to come. We're going to start with the Q&A part of this news conference, and we'll start out here at JPL. If you do have a question, please raise your hand. Wait for the mic runner to get to you. We're going to go in the first row first on this side, and state your name and affiliation, please.
Leo Enright with Irish Television. Could we get times on the major events for Sol 3, I guess, the HGA deploy and the Mast and so on?
Sol 2, yeah.
Oh, sorry, Sol 2.
Yeah, I'll provide those to you right just after this.
Okay, and if Ken Edgett could maybe talk to this picture, could you, about the geology? I mean, there seem to be 3 distinct geological regions, and is that the thermal inertia zone there that we're looking at?
I've been so busy with this Molly stuff that the team, Gratzinger's right here, the team has been off discussing this all night. But you can see between Curiosity and the heat shield, you can see the heat shield is on a surface with lots of small craters, and Curiosity is on a surface that's a little bit more with rounded hills and fewer small craters. And then sort of above or north of Curiosity and the heat shield is this lighter toned terrain with lots of little buttes and mesas and pits. I don't know what the team's been talking about all night, but if it was up to me, I would go to where those 3 come together as a starting point, because you can start to get a flavor of what's going on here in terms of the different geologic materials. Do you want to say anything, John? Or I just made that up.
The high thermal inertia stuff.
Okay.
All right, we're going to take another question that actually was in the same row, but 2 people to the left.
Hello, Olivier Sanguy and geospace.com from France. You said the distance, for example, for the sky crane was around 600 meters. That's right?
Between which components?
Curiosity and sky crane, for example.
And the sky crane, yeah, 650 meters approximately.
I'd like to know, is it planned to have Curiosity going towards the sky crane, the back shell, for example, like you did with one of the previous rovers to make a sort of engineering checkup, or is it not a scientific target?
The question is Curiosity intending to go back and visit those? No, it is not.
Okay, let's go right directly behind you if you can hand the mic back to the second row, and then we'll go over to this side, second row.
Hi, Eric Hand with Nature. My question is for Ken, and maybe we can start with this picture and then go to your picture. So you're on this medium-toned deposit here. Yesterday, your boss described it as being a classic lag deposit, and wondering if you can kind of add your interpretation to what you're seeing in the foreground of the Mali picture. What could possibly be responsible for all these sort of walnut-sized little pieces of rock in the foreground?
Squirrels. Dude, walnuts, got to be squirrels somewhere. You said Mike Malin was here yesterday, talked about this lag surface. That's based on what you see in the Mastcam and now the Mali image. From what you can see in the orbiter image from the high-rise, and this is true from the high-rise we had before this one, you really can't get that far, right? Because those particles are so small, okay? So how what you see in front of you in these few images we have extends out over that patch of terrain, I'm not going to go there. I want to drive around a little bit, and I want to see what the nav cams and mass cams show before we, I don't know how extensible what you see around the rover is. You also notice that the dust has been blown out of there, right? So.
Okay, we're going to take this question, and then we're going to go to the phones.
Irene Klotz with Reuters and Discovery News. Ken, what time are the dust covers going to come off on Mali? And once they're off, do they stay off, or do you operate them as a protection if there's a dust storm or something?
Yeah, the Mali dust cover, which, by the way, I forgot to mention, is actually totally transparent and clear. So if it had no dust on it, you'd be seeing it as if there was no dust cover, that scene. That dust cover is on a hinge, and it'll just open and close whenever we want to open it. So unlike the Mastcams, which pop off and stay off, we most of the time keep this one closed. When we want to look at something, now that we know it's got dust on it, we're always going to want to open it to actually look at something. So we will just command it to open for that short period of time and close up again so that we don't get dust. We're on a turret, and there's a drill, and there's a sieve, and there's a brush. We're going to be making dust with the turret, and that dust could get on the Mali. Okay. When we were selected, we were told, expect Mali to get dusty. Of course, they meant because of the drill and all that. They didn't mean because the first day you get there, you're going to have some dust. So.
Thanks. And I was also just wondering if anybody's done any calculations of how deep into the Martian soil those various discarded elements went. Like what sort of impact did it have?
Based on what we're seeing in the images, you mean, or in general?
Probably more from calculations of the mass and the speed of impact of sky crane, things like that.
I'm not aware of a depth of penetration calculation. I don't know, John, do you know?
It's still early.
No, I mean, a model.
Oh, a model, yeah. Well, that would be dependent on the regolith.
Yeah, it depends on what
properties.
you hit. You hit rock, you hit, soft, dunes. Those would matter. In the case of the descent stage, the sky crane, it matters a lot how much fuel was in it and what the final mass was, things like that.
I guess I was just wondering, after missions, Lunar Prospector and Deep Impact, where you go and try and make a hole and get some fresh material, if you'd ever have any scientific use for, obviously you need to sort out the man-made parts of things.
Well, we did. So actually, in the case of MSL here, we actually kind of want to stay away from these because we don't want to be contaminated by them. I think we talked a little bit yesterday that the balance masses, the ballasting weights that come off, those are inert. And those could excavate a nice area, and we actually did talk about that. In fact, I think John might have mentioned that yesterday. But their ballistic coefficient is so different from us that they land very far away, and we're very incredibly unlikely to find them. But that would have been a very good object to excavate.
I just meant even for future missions, orbiters, things like that. Thanks.
Okay, we're going to take a question from the phones. First, we're going to hear from Clara Moskowitz at space.com. Go ahead, Clara.
Yes, hi. My question is for either Michael or Ken. I'm wondering if you can talk a little bit about the emotions among the team members now as you transition from the euphoria of landing to the day-to-day operations.
Yeah, well, I think I can answer that in two ways. The surface team is pretty excited still, because I think I mentioned yesterday, this is the start of our mission, and there are a lot of folks on surface that have been, practicing and training and learning for years to execute these early parts of the mission, and it's great to actually put our rover through through the motions here. It's also great to keep looking around the neighborhood. I said this yesterday. My favorite images are always these first few images because you first get a chance to really see where you are. And I think the emotion of those, every time we get a new one, we all crowd around the screen and and watch the first images come up here. And we're still doing that just as much today as we were on landing night. But it is interesting. I mean, the rooms are a little bit less crowded with with onlookers that are not on the team, mostly because it's occurring at 3 o'clock in the morning. But I think the service team is still pretty excited. But there's a lot of long hours, I think. So the adrenaline will last for a while. But I think a lot of folks are working late at night on Mars time, and I think still getting adjusted to that. But these are the days that people worked 5 and 10 years for, going on right now.
All right, we're going to jump back to the room here at JPL, then we'll get back to the phones. Let's go ahead and take that question right there.
Yeah, hi, Mark Kaufman with the Washington Post and National Geographic. Some of this you may have gone over yesterday, and I apologize if you already had, but in terms of your situational awareness, as it were, do you know how far you are from Mount Sharp or from the crater wall? And is that the crater wall we're seeing in the back? So just if you folks could give us a sense of where exactly in the crater you are.
Gosh, it's funny because, since we put that picture out, 12 hours ago, it's like, oh yeah, we yeah, that's the north wall of Gale in the Mali image. And we're facing pretty much due north with Mali. And
so just to be clear, just clarify,
yeah.
so not to interrupt. The rover is facing kind of east southeast, right. and Mali is off to the side. So the Mali lens is facing due north. The rover is facing kind of more east southeast.
And that distance to that wall is roughly 20 to 25 kilometers, I think. And my recollection from what Jennifer was saying here yesterday, that to the mountain, it's something like 6 kilometers as the crow flies, or something like that. Is that
from the high-rise image? We estimate, and again, this is rough because it's this sort of skewed perspective, from the rover to the point, directly to the point at which we're thinking Curiosity is going to start climbing up, is about 12 kilometers.
Okay, more questions here at JPL. Let's go back to second row back there, Todd Halverson.
Thanks a lot, Todd Halverson of Florida Today and USA Today. I have several actually. Could you go over again what you are going to first get from Mastcam? When you think you'll have the first panorama of the neighborhood, and you mentioned Mars time right now. What is the work shift that people on Mars time are working right now? It sounds like it's overnight.
Okay, let me try to remember all those questions. So we are taking a Mastcam image of the Mastcam calibration target. And that's the first thing that we're doing. And we're going to do that here on Sol 2. We're also taking a Navcam 360 panorama, and we do that in what are called tiers. So you can kind of look down. Imagine kind of looking your eyes down and then walking around in a circle, and then looking a little bit more this way and then around in a circle. We're taking those two tiers. We're not taking the upper tiers yet. And that will also be executed on Sol 2. And I think both of those will give us a chance to take a look at our own rover as well as as the neighborhood around us. Mars time was the other question. So the Mars time, we actually are staffed nearly around the clock. The prime start of the day for us is when the rover's day ends. So the rover day ends on Mars around 3 or 4 o'clock in the afternoon, in order to be timed with the orbiter overflights, with the MRO or Odyssey overflights. So the rover tells us what it did today, and then sends that data down to the Earth. And then the team then wants to take a look at that and plan tomorrow based on what happened, based on what she told us her status was at the end of her day. And that occurs for us, as you remember, EDL happened around 10:30. That was under those overflights. And so those are moving by the difference between the Mars rotation, Mars day, and the Earth day, so about 40 minutes later every night. So that shift of people coming in, taking a look at the latest data from the rover is now starting, 11 and 12 o'clock at night, and then going about 8 hours, and then another shift comes in to continue the planning for to complete the sequences.
Okay, we're going to take a question from here, and then we're going to jump to the phones. Let's get the blue shirt right behind you, Jody.
Thank you very much. I'm Fernando Correa from Tercer Milenio in Mexico. Congratulations first. The question is, exists something to do to clean the dust from the lenses, from the instruments? What are we going to do?
Well, the Molly has a dust cover so that we are protected from dust. The fact that it's clear and we can see through it was really just in case it never opened for some reason. So we will open it and then we're clean. The hazard cameras, as you know, their covers already came off. So any dust that would accumulate now but they kind of point down. The cameras on the mast, right, the nav cams, the Mastcams, the ChemCam, those are, which will deploy now. Typically, and you can confirm, typically you'll point down when you're not operating so that dust settling from the sky won't accumulate on those. And that's pretty standard on Opportunity and Spirit as well, right?
Thank you.
Okay, we're going to jump to a call on the phone right now from Houston, and it's Ian Page with KPRC TV. Go ahead, Ian, if you're there.
Thank you. Yes, I am. Probably for Ken. Ken, can you just talk about the significance of these color pictures, which are giving us a look at Mars that we've never seen before, and just how thrilled that you guys must be about these pictures?
Did you see the Marty descent images yesterday? I mean, yeah, I work for this very small company down in San Diego, and we built 4 of these color cameras on this rover, and we now know that 2 of them are working. It's too emotional for me. It's been a long journey, and it's really awesome, and that's all I can say. Did I answer the question?
Yes, you did.
And I'm tired.
All right, let's take some more questions here at JPL, and I see we have several hands, so let's start here in the 3rd row, and then we'll jump across the aisle behind you, green shirt.
Hi, Henry Bortman with Astrobiology Magazine. A couple of questions. The relative data rates of the high-gain antenna, the Odyssey path, and the MRO path, could you give us that information? And is Odyssey going to continue to be the main way we get stuff back?
Yeah, for sure. Odyssey and eventually MRO are by far the prime ways we get data back. The direct to Earth is really not a primary way to get science data back because the data rates are just too low. The relay rates, the relay orbiters, we actually can adjust those, and they're set to kind of low rates for them, 8K for Odyssey and 32K for MRO. But we're about to up those rates, and in the case of MRO, we could actually get up to close to 2 megabits per second. So MRO, the radios on MRO and Curiosity actually can dynamically adjust the data rate depending on how good the link is, and they can zoom it up to the maximum rate when we activate that feature later on. But in these early days, we're trying to be careful. We're trying to keep the signal to noise ratio as high as we can and be kind of conservative. In addition, when MRO activates all of its science instruments, the CRISM instrument and MCS, and we had HiRISE and all of these instruments, there's a little bit of interference, and so we want to characterize all of that before we commit to the final data rates. So right now, we're still getting the vast majority, and we'll continue to get the vast majority of data through the relay orbiters, but we're about to get much more per day than we're getting now. 4 or 5 times more per day.
And a dust question. There's been a lot of talk about dust on the dust covers on the cameras. Before EDL, there was, in the description of the process, one of the reasons for keeping the sky crane high off the ground was to prevent dust. And I'm wondering if you got more dust than you thought you were going to.
It's hard to tell. I think there's a variety of opinions about how much dust we're going to see. I think you can tell because we put dust covers on all the cameras, including the Mastcams. We were concerned that we would get some. I think it remains to be seen how much we've gotten. It certainly looks like there's a fair amount of dust kicked up by this thing. But the rover is designed to be largely tolerant of dust because the longer you sit out there on Mars, you start to get covered with dust. Luckily, we don't have the solar panel situation. Spirit and Opportunity were sort of blessed by these cleaning events that kept them going. But we thought of that as one of the methods of decline of MER. And so we're not subject to that. So we think we're pretty resilient to a fair amount of dust, but it remains to be seen how much we've got. And I think some of the images we're about to get back, where we can self-inspect, will let us know a lot about that.
All right, the next question, we're going to take it, Jody, right behind you. Scott, can you raise your hand? Green shirt, yep.
Good morning, Scott Gold with the LA Times. 2 quick questions. Sarah, there was some kind of giddy speculation immediately, when the first images immediately arrived, that you could see the descent stage, the sky crane crash landing in the background of one of those images. Now that you know where everything wound up, where all the pieces are, can you kind of either put that to rest or not? And then secondly, Mike, can you kind of explain a bit more about the REMS test that did not work the way you had hoped exactly, and sort of explain a bit more about the significance of that and how difficult a fix it is?
If we could show that kind of the crime scene photo with all the components on it.
Okay, Sarah, we'll get that up for you just
Okay.
a second.
So do you want to?
Okay, it should be coming up.
Okay, we'll just run through. So we know where everything is sort of with respect to each other, and we know which direction Curiosity is oriented. So what precisely we saw in those images, I don't really want to speculate about at this time, but you can see that. So you can see Sky Crane and Curiosity, and then if you just remember which direction that is, and then go forward one step, if you could. So the rover, the rear Mastcams are pointing perpendicular to that dust streak there, and pointing up to that corner. And so yes, that's the right direction for the Sky Crane. But what precisely we saw in those images, I think the team has to talk about, and we have to mull that over a bit more.
Yeah, I think we're still thinking about it. I don't think you can rule it out based on this image.
Okay, that sounds intriguing. Let's go over to this side of the room. And the question, blue shirt, right, a couple rows behind you, Jody. There you go.
Oh yeah, REMS.
Oh, I'm sorry, Scott.
Yeah. So let me say 2 things. First of all, we have a great REMS team, and they're off working this, and a principal investigator and a whole team of engineers working on REMS, and they're working this problem. And I don't really want to speak for them because they're off looking into this. Our first take on this is the first checkout worked fine. They do all this checking of the file that they're about to read to execute the next set of observations, and that file did not look like it had the values that they expected. And I think things like this are a class of thing they've seen before, and it's in the past has been just fixed by changing that table. So I would say that it does not appear to be significant at this time, but these guys are off working it, and it's it's their baby, and let's let them think about it for a while. I mean, John, do you know any more? Do you want to comment?
Okay, then let's go ahead with the question, and then we'll go. Let's just take you first.
Okay, thanks. Kelly Beatty, Sky and Telescope for Ken, Mr. PI. Are the RGB filters on Molly the same as on the Mastcams? Will you be able to balance the color, do the white balances and such the same so that you get consistent results with them?
It's exactly the Molly, Mastcam, and Marty all have the same CCD. It's a Bayer pattern, the two times green and versus red and blue. So Yeah, we'll be able to perform all those things. It's a little challenging when we have this low contrast image that we have right now, but yes, and it'll all work great.
Okay, let's go to a question back there.
Hi, I'm Rafael Garcia with Folha de São Paulo, Brazil. Once you get the mast deployed, are the cameras in the mast high enough to try to spot the sky crane, the heat shield, and the other things?
I think they probably are. It depends a little bit on the local topography. I think if it's pretty flat, we have a decent chance of seeing them. John, can you comment on this?
Yeah, they should pick it up.
Can we get a mic up to John right here?
He said yeah.
No, he agrees.
They should pick it up.
Yeah.
Okay.
Yes. He thinks yes.
It depends a little bit. Make sure that depends on how flat it is between us and them.
Okay, let's go up to right there.
Emily Lakdawala, the Planetary Society. I'm wondering, how windy do you expect this site to be? Do you expect it to blow dust off? Do you expect it to blow dust on your equipment?
The dunes are actually known to move from high-rise images taken over time. So that's a windy place. So what we'll see in terms of dust removal remains to be seen, but get a little closer to that dune field, maybe. And
okay, has anybody, yeah, let's go to Frank Mooring. You haven't asked a question yet, right here in the second row. And then we'll get some repeat questions if we have time.
Frank Mooring with Aviation Week for Ken, and I guess maybe Mike. Given the Turner-esque beauty of your first color shot, when could we expect to see a clear picture, maybe from that camera or from one of the Mastcams?
Well, from the Mastcams, as Mike said earlier, on Sol 2, they're going to get pictures, their initial, just like we did with Molly, looking off where we're pointed, they're going to purposefully point at their calibration target, make sure the mechanisms are working, get in focus, the whole thing. So that should be, tomorrow we would see that, I guess.
Yeah. Would there be any terrain in any of those early pictures for tomorrow?
The nav cams certainly will have terrain in them. The Mastcam probably not.
Well,
right? Just a little bit off to the sides. It's focused on the cal target,
you'll see
right?
some, in the one camera, you'll see some of the dirt down below the rover in that direction. Yeah.
And just for Mike, has anyone had a chance to look at the crime scene here and see if things sort of landed approximately where they were expected to land?
Yeah, I think they have already. I've seen some email with the EDL team saying that the layout looks pretty much the way they expected, and they kind of I think they would kind of simulate it this way.
Okay, any more questions here from somebody who has not asked a question yet? Yeah, let's get a mic back to the fourth row there, fifth row there. Yeah, there you go.
Frank O'Brien, americaspace.com for Ken. You were mentioning that there could be a fair amount of winds. Would that be enough to start the parachute billowing up? Would we be able to see that? I mean, just to get a feel for the idea of how intense the breezes could be.
As you say it, I'm processing. We can take video with the Mastcam, and I don't know the answer to that question.
Okay. Did you want to say anything more? Or? Let's get a mic over to Rob Manning there.
Move.
In the images we've taken of other landers, the parachutes have stayed put under pretty large wind conditions. So our anticipation, we expect that it's hard to do. I mean, the atmosphere is only 1% that of Earth, so it takes a lot of work. I mean, to move these sand particles, these particles are only bouncing a little ways off the ground, even these larger sand dunes. So we don't expect a lot of big gusts like we have on Earth. But it's enough to move, and especially if there's dust in the wind, it's enough to move other particles, and that's how we get dust cleaning events when dust particles hit other dust particles and they knock it through, just like a sandblaster.
Okay, let's see. Let's take a question. Let's go back to Eric, right here in the second row.
Hi, yeah, Eric Ham with Nature. Just a quick question to clarify something. Yesterday, Joy Crisp told us, I think based on Mike Malin's location that the base of Mount Sharp was 6.5 kilometers away. You just said 12 kilometers away.
Well, it depends on where you're defining the base, like, and if you're going, you know, which way you're going. We did a rough calculation to the point in one of the early speculative traverses of where the rover would start climbing, and it's versus if you're just going to draw like a straight line to, you know, some other feature. It's a big mountain.
Okay, so the 6.5 is as the crow flies to the base.
I'm not. I would have to. I was.
Actually, Joy is here. Joy, do you want to
Yeah.
clarify?
Oh, let's get a mic over to Joy Crisp.
Yeah, this is working. It was 6.5 kilometers straight, and working with other geologists, they were showing me how difficult it is to define the base, so there's that issue too. Same with the rim. In some places, it's hard to exactly define where the rim of the crater is. So 6.5 was an approximate distance straight from the rover location to where you could, like the very first start of Mount Sharp, sorry.
Any more questions here at JPL? Okay, let's go to right here in the aisle.
Olivier Stanguier, geospace.com again. A question about the Mali camera at the front, on the robotic arm. What is the minimal focus distance, and what resolution can you have on the soil of Mars with that camera? And I suppose it will help for the sampling process. Could you describe how you will have a working operation with a guy who will do samples?
How we'll work with the sampling.
Yeah.
Yeah, okay. The Mali, as I mentioned, you can change the focus. You can focus on things as close as, it's literally 2.1 centimeters, which is about an inch, out to infinity, basically. At the closest distance, the resolution is 1414 microns per pixel, okay? And the MI on opportunity is about 31 microns, so it's about twice as high. But we have to get that much closer to the target. But we can be at any distance from that, and we will probably take, you know, a really high resolution, then a context, and then another, you know, step out, and you can take those samples in there. So it's pretty versatile. The arm will use the Mali to do Mali science, but we're also going to be supporting all of this sampling. You've got to document where we're going to drill, document where you're going to scoop. We're going to deliver sample that's been sieved, not only to the chemin and the SAM, but also to a little round tray called the observation tray. It really is it's 75 millimeters across, that the APXS can look at. And so we will document that with the Mali as well. So we can also, you can open the SAM, or the chemin inlet cover and look down the hole. So if you think there's any kind of a clog or something, you can diagnose that. So it's an amazing thing. We'll be able to look back at the rover, take pictures of the rover. We'll be able to look under the rover in focus and, you know, document what's under the rover.
Did I mention the LEDs too?
Oh, and it has LEDs, so we can take pictures at night. We can.
Could we use a sort of diagnosis camera if there is any problem, which I don't?
Yeah.
Yes.
Yes. Well, and you'll recall on a previous rover there was a situation where they had to look under the rover because a wheel was stuck, but in that case the camera could not change focus. So we can do focus now. So, and in color.
Okay, we only have time for one or two more questions. Let's go ahead in the third.
Mark Hoffman again. From the beginning, everyone has said that the most important things that you're going to find are the things that are surprising and that you don't expect. Anything pop up so far that was different than what you had imagined, anticipated?
Oh, who's he talking to?
I would say from an engineering perspective, it's gone as well as we could have imagined. So it's been unsurprising, which is fantastic. From an engineering perspective, I think that's how we like it. I think from a science perspective, it's just too early in the mission to tell. But I am confident there will be a lot of surprises when we start looking around.
All right, let's hop 3 rows back to Todd.
Thanks. Todd Halverson of Florida Today and USA Today. I was wondering what exactly is the Mastcam calibration target, and when you suppose you might shoot the ChemCam laser?
I'll let him do the laser because I don't know the answer to that. The Mastcam Cal target is the flight spare of the Spirit and Opportunity PanCam Cal target. So it was actually, you know, a flight spare. It was ready to fly, but it didn't have to. So our co-investigator Jim Bell outfitted it with a little bit different decoration on the side, but otherwise it's the same. And there's also, we added some magnets, which will keep, just like on the Phoenix SSI Cal targets, will help keep little circles clear of dust, you know, in each of the color and gray elements on the target. And it has that gnomon, that little ball on a stick thing. So.
Okay, let's. I'm sorry.
Okay, so we have a script that we're trying to follow here, and for what happens on what sol number, and if everything goes perfectly, it's kind of scheduled in after you know, we do a flight software transition to this sort of new set of flight software, new operating system designed for surface. It's just after that, so probably around sol 11 or 12 or something like that. But that's kind of assuming the next week goes perfectly and nothing, you know, nothing slips to the right. So I'd say the earliest is around that day.
I think we had a quick question in the first row, Leo, right there.
Yeah, sorry, I was doing something else. I was wondering, I know you guys have had a long day, but for the inner geek within us, I was wondering if it's possible that somebody from the science team could spend a bit of time after the briefing going over this extraordinary high-rise picture. We really need some help interpreting what we're seeing, and it's not appropriate, I felt, for this sort of a briefing.
Okay, that sounds plausible. Let's take one more question, and that would be right there.
Kelly Beatty, I hope this is a suitable wrap-up question for Mike. Now that you know where you are, has the team started contemplating where you're going to send the rover, how you're going to approach it? I realize there's a lot of contingency. And maybe you haven't, and if you haven't, at what point will you?
So the way we try to do that is, you know, we've worked with the science team very carefully here to come up with a plan of checking out the rover and making sure that we're safe and ready to operate. And then we kind of start handing over the keys in terms of where we're going to the science team. So right now, every day, the science team is meeting and looking at these images and trying to decide what the highest priority targets are, you know, both in the local vicinity, you know, the high thermal inertia unit and this alluvial fan, as well as progress to Mount Sharp. So, you know, so I think we're going to let the scientists decide what the highest priority scientifically is for them in terms of which direction we drive and where. But you know, that's a couple of weeks away because we have a couple of weeks of checkout here to go through at least, and the science team will use that time to, you know, to make good decisions about where to go.
Thank you very much to our three panelists today, and for everybody else, I just want to remind you that the next news briefing is scheduled for tomorrow morning at 10 a.m. Pacific time. After this broadcast, immediately after the broadcast, we will replay the visuals you just saw in this briefing. And remember that there is lots of info and images available 24/7 online, www.nasa.gov/Mars. Thanks for joining us this morning.